I'm Andrew Armstrong and welcome to the Back Office Teardown Lab. Today I have a very exciting kit. It's called the Kuman JYE DSO, Digital Storage Oscilloscope Shell DIY kit with open source 2.4 inch colour TFT LCD shell, do-it-yourself parts and everything, and it's the 15001 Camel, whatever that means. Now, you might have seen in the Patreon video when we covered this, we unboxed it a little bit, and I was absolutely ecstatic because it comes with everything. And I'm just going to spread it all out, and then we're going to go through the parts you get. It does look like really spending more money on the more expensive kits pays dividends. That's the vibe I've been getting recently. When we've been spending that little bit extra money, we get something with better instructions, better parts, easier to make, faster to make. So this kit comes with not only a shell and a set of BNC leads. No, they're not like great probes, but to be honest, I don't have a set of clippy probes, and I think that's pretty useful. But it does come with the main hardware partially assembled, so that if you don't fancy playing with surface mount components, you don't have to, because all of the surface mount components have already been fitted for you. Look, there's one part there. Let's turn it round, have a look. So that's what this is. Is this the input stage, perhaps? Looks like it could be. Then you have this part, which is the main body, you know, the screen. I don't know. Oh, you can stick that down. It does have some sticky. I'm surprised they didn't bother just sticking that last bit down. How's that attached? That has actually been soldered on there for you, so you can test that before you stick it down, I'm sure. And let's look at the back. You have an STM32. Great chips, by the way. Little ARM chips, and it's running everything with an 8 megahertz crystal. And is that a diddy bit of flash in there? Whatever that is, we can go through. And then you've got a regulator here, which is a 3V3 regulator, and it's pretty simple. So let's have a look where this board might just fit on here. Interesting. I'm just looking at these jumpers on it. I don't know. That's my honest answer right now, but that's fine. We're going to look in the instructions, because I did have a quick flick through the instructions, and it implied that there's a testing procedure before you even start assembling it. So here's the user manual, and it's telling you how to solder the SMD parts, which you don't have to do. It's already been done. Oh, and then we have these checks here, look. Check step 1, look, check the main board. So it's showing them actually checking the main board with some components fitted. It's really weird. I'm gonna guess here that it wants you to check the main board and then fit the components, because this is clearly step 1. The main board is powered up and running, and in the instructions they say this is the first test. They say if you plug it in and you don't get anything, then send it back right away, because there's no point in continuing. So you can see here the main CPU is running, it's powered on, it's showing random data really just coming in because the analog board's not even attached, and I think most of the digital board still needs to go on here. So that's a good first sign. I think with that we can proceed to actually assembling the next parts. Let's make a start, shall we? So the first item is the test signal terminal, which you can see here is just a Lucas terminal, or Lucar terminal, and it suggests we have to fit it right in there, and it will give a 1 kilohertz square wave. So to do that, we're going to need to bend the pins on it. Huh. Clear out my pliers. There's something jamming the jaws up there. So we'll just do a nice little bend to get 90 degrees there. And if you've got a bench vise, I suppose you could do that too on there, but that's okay. We didn't need any vise, and we're just going to push that in like that. I'm just going to solder it from the top, I think, and we'll touch that up later. If you can, that'll save you a lot of time. You won't have to worry too much about the placement. However, if you're a stickler, you can make sure then each part is individually placed and seated. I tend not to do that. I'm just looking at this though. I think I could have bent that probably a bit more aggressively. Now I'm not so sure if I want to, because it could damage a PCB, so that's okay. That was alright. Not much to trim on there, so don't worry. Next part, power connector. The little Molexy type power block. Where would that live? It says it's optional, interestingly enough. I guess it's going to go on the bottom here. Ah, here it is. I'm going to pop that there. Again, that's one that you could actually pretty much solder from the top too, so we'll try that. This whole top soldering, I think, is really handy. We've been doing it a lot recently, haven't we? You can't do it, of course, on a kit that's got a single-sided board. But I'm going to zoom in though and show you this one, because I'm going to touch this one up. And I know that there are people watching these videos who've never soldered, so it's good to learn both ways. And I would say start with learning this way, what we're doing now, because that's the more correct way. And if you want to do it as you go along though, just take your side cutters and snip the tops off all of these leads and things that you're putting on. Keep them nice and neat. Right, step 4, the slide switch. So see, there's only one slide switch in this kit, and again it's going to go on the bottom. It's a 6-prong device plus 2 anchor points. So I'm just going to push that through, and again, yeah, let's do it close up. I know you guys are veterans of the channel and you've seen this happen a million times, but if you haven't, look, that's all you need to do. When you get any component, just line it up, make sure it's the right way around. Here, for example, I've got a bent pin that's going to prevent me from putting that in the board, and I'm just going to unbend that, attach, little kiss, give that a little kiss, and it's going to go in, hopefully with little problem. Get in there. Now if you feel something doesn't want to go in, it's taken a bit too much force, like that switch did take more force than be expected, but don't force it too much because you might be bending something. That's okay. And then just take your soldering iron, hopefully clean. If you've got flux, put some flux down. Most of this solder's got a bit of flux in it, it's okay. Heat the component lead and then just let that flow in. Flux is always handy if the board as well is a bit dirty. But you know, it's something else you got to clean off. So if it's through hole stuff, I generally won't put too much flux on things. It's easy enough to deal with. There we go. Step 4, the pin header. So we're going to apply the little pin header here. Don't think we apply it. We're more inserting than applying, but whatever the vernacular. This one's slightly different because I am doing it the correct way, as in soldering from the rear of the board, but I'm just going to hold it up as per usual, putting a little bit of pressure with my finger just to make sure it's sat right, and it is. So I heated that tack joint, made sure it was sitting right, and then just finishing off the rest. Good. Step 6, the tack switches. So that's clearly the front. So we've got 1, 2, 3, 4, hopefully. Yes, we have 4 switches. I'm going to zoom out a bit. It feels a bit claustrophobic sometimes when we're a bit too zoomed in, isn't it? I'm going to pop those in. Now those legs are a little bit bent, but not too bad. I do like this. I've got one of the original DSO pocket scope things, which may or may not be derived from the same project, who knows. And one of the problems I had with that is it just didn't have enough buttons, so I don't know, hopefully this has enough buttons when we're done with it. But if you're used to using a bench oscilloscope, you'll be used to having all of these buttons for everything, and it really is annoying if you have to scroll wheel and have many variants. I mean, those original ones, DSO pockets, they had several buttons and a scroll wheel and some other stuff, and whichever combination I seem to use, it was always the wrong thing. And I even changed the firmware to some later open source community firmware that was slightly better, but I have to admit, last time I fired that thing up I was clueless as to its functionality. I'm just looking at the front here now because I'm noticing the buttons are a little bit jiggly, so I'm going to do something else. I'm applying heat to that tack, but I'm literally putting a little bit of force on it, forcing them towards the bottom of the PCB, in and towards the bottom of the PCB, so that they all align up. Hopefully they're not going to all align badly, but at least they will be aligned. So now they're as straight as we're likely to get them. We'll just finish off soldering, because I just noticed in the front panel they go through some holes, so you either want them all right or you want them all wrong. You can deal with either, but you can't deal with some right and some wrong, because that's going to be a nightmare in how you're going to have to shim the case, wiggle your PCB around to fit. And we're just feeding solder in on those joints, and I'm holding the soldering iron there just for a few moments till I see it flowing in. And I guess you want the full ASMR experience here, and you can see that on those last ones. I'm going to hold the soldering iron there along the side, feed it in, and then boom, nice. That one's good, and that one's good too. So step 7 says remove resistor R30. And it says here R30 is used to bypass switch 5, so the mainboard can be tested without the power switch. It must be removed for the correct functioning for the power switch. Okay, so it's a 0 R, I'm sure. And I'm just studying here because we've got to find it. There's R30, and indeed it has a 0 written on it. So you should be able to find it too, just next to the power jack. And if you don't want to get rid of it totally, because I don't like, what else are you going to do with it? Just chuck it in the bin. So just heat it up. And you can sometimes just do it from both sides. Just heat one side, heat the other, and you can just push it around a bit. Bully it around. And you can see that I've still got it on the board. It's just not connected. I'm gonna sit it flat because it's tombstoning. And you can see it right there, just disconnected but on the board. Now, the next stage is the fun stage, because it is the resistors, and they actually have quite a nice little checklist here of all the values, but they don't have the colours. So they say on the instructions, use a meter to sort them out. So what I will do is I'm going to arrange these and then we'll solder them. Yeah, I might have jumped the gun. I did say I was going to sort out the resistors and then fit them, but as I started looking through the parts list, there's 15 resistors and only 3 of them are the same value. So I think we'll just do it as we go along, but I'll show you what I'm doing before I zoom in, and then you can see the process I'm following. I'm basically taking my multimeter and I'm putting it on resistance mode and then touching it each side of the resistor, and you can see here 2.99 kilo ohms, so that's going to be a 3 kilo ohm, and according to the instructions just in front of me, that's saying R13. So then what we're going to do is have a look on the PCB, and I'm not quite sure if it's the analog. It probably is. It is the analog board. We're working on the analog board now. So R13. Thinking, scanning. Where are you, R13? Shout at the screen now, loudly, so I can hear where R13 might be. And there it was, under my nose the whole time. So if you want to do it one at a time, just poke it through like that, flip your board, and it's sitting nicely there. I would follow the instructions in terms of their order, by the way, as in component order, not necessarily resistor order, because they are starting with all of the low profile components first and then moving to the higher profile, so it makes life easier if you're doing what we're doing now. And we're going to take now the next components. You can see again the process, randomly pulling a resistor from the pile, touching it on my probes. 29.9. So do we have a 30 ohm value in our list? And I'm looking at the list. No. Hang on a minute. There's our list. Let's just do a sanity check here. Oh, we do have a 30 ohm. Tell a lie. 29.9 there. And 30 ohm here is R10. Phew. That was a bit of a worry. So then I'm just bending the leads round. If you do have a bender, that could work for you. I'm going off-piste with this one. I'm just keeping it real. Because again, I know a lot of us don't have those things. And if you wanted to, you could poke all of these resistors in from the top and use your bitey hands like that and just hold it. In fact, let's just do a few like that. So that was the R10. I'm going to get another value, and I'll show you why, by the way. And this next one is 15 ohms, and a 15 ohm is in R11 or R12. So looking here, so there's, oh no, I think I got it wrong actually on that last component, because I think I put our R10 in the R11 footprint, so that's just as well. So we'll just fish that out. Pay better attention than I did. So if we were soldering as we went along, that would have been a bit of a bummer. Woohoo! Glad we didn't. Okay, so let's see the next value we have here. I'm just going to do one more and then show you. And we have 148.6 ohms. And I don't see that value in my list, but I see a 130 and I see a 150. So I'm going to go with 150. We have two of those in R8 or R16. So let's look for an R8. Well, I can see R16 and that's good enough for me. So I'm going to put it in R16. And the reason it's nice with the helping hands, you can solder from the top again on this board. If you can't solder from the top of the board, you don't have the helping hands, then just flip it over. Flip it over and solder. Just make sure that they're sitting nice and flat. So that one, for example, you can't quite see it, but it isn't sitting flat. So I'm just going to push it with my finger and then just heat the solder again to allow me to adjust it. And I will be turning these round later and soldering from the bottom as well if it looks like it needs it, but that's keeping them in place. They're not going to get lost right now, and I can just continue. So why don't I get on with that while you enjoy the magic of video editing. Ooh, ooh, ooh. Now, I'm very pleased to tell you that all of the components were there and they all went in the right places. You get a little bit nervous by the time you get to the last component, because if that last component's not the right value you were expecting, then it means you made a mistake somewhere else. Now, just one thing to be aware of: when you are checking for the values, you've got to remember that you're measuring resistance, and of course, if you see there, I'm jamming it into my fingertips. UMONs have a resistance value too, and when you're working with components that are at 1.2 mega ohms, you can see there that I'm not too far off that. You know, it's 1.4 mega ohms, so my value will adjust the reading. So make sure you're not touching the tips. You're just, or maybe just one of them, and you're using just the your finger on the insulation. Okay. Let's not worry about that right now though, because we've already done it. And now we're going to do some top soldering, as in just from the top, not top as in this is the best soldering you're going to see, but hey, I think it's pretty good. Although, you know, many people like to criticize soldering, but you know what? Just ignore them. If it gets the job done, that's all that matters. There's no artistry. People like to think they're some sort of PCB artiste. Yep, whatever. Once you've done a million joints, you kind of know what just works. Just do that. If it looks fine enough, that's good. If it's not a total mess, then it's okay. You know what it'll be. You know what a bad joint will look like. And experience will tell you fixing soldering joints, fixing mistakes, fixing problems take like 10 times longer than just doing it right in the first place. So you've got no incentive to do a bad job anyway. It's all down to practice and skill, and just learn it at your own rate. And I think looking at that, that's all of those. So that's good. We're in a position to flip this board over. And you can see, got a lot of legs now. I can do this. Look at that. I can turn it. science. I don't think there's too much need to top these off, actually. I think they're looking pretty good. If you see any that you think could be a little bit dry, you want to add a bit more solder, then just go ahead. But I think electrically we're pretty good. It's just, I was going to say aesthetically. I almost said ergonomically, but I don't think that's quite the right word there. I do not think that word means what you think it means. So get your side cutters and start lolloping these off. Now do it one leg at a time. And I don't know what happened to them, but do you remember I had those black side cutters which had the little retrieving technology that wouldn't let your lead ping off? They were quite good. Just eyeballing my desk there, and unfortunately don't see one. Just to show you what a shaved one looks like there. That one is clean shaven, and these ones are yet to be done. I'm pretty convinced of that all round. That's good. So next it says we need to install the ceramic capacitors. So I'm just pulling those out my pile. I'll show you. Don't pull it out your piles without care. Otherwise you'll get all mixed up. But that's what ceramic capacitors look like. And if you turn them around, which way and what way, which way around, you'll get some measurements on them, values, and that's the right values for the right holes. So let's see if we can see some ceramic capacitor holes. In fact, these are marked C1, C2, so you're going to have to refer here and see what is C1. So C1 is 0.1 microfarad, and don't know which one that is. Could be that one. C2 is a 330, so that's definitely C2, and I can see C2 here, so I'm just going to park that there. We'll zoom into that in a moment, but I'm just leaving it sticking up out of the PCB. You can just about see that sticking up out of the PCB. And what else do we have? We have one here which has a 151 on it. So we have a 0.1 microfarad. We need a 1 picofarad. And we need 150 picofarads. Probably should have just done this sooner, but on Google image search it's got a picture here to show you what the different markings are, and it seems it's like the last digit is how many tens you have. So if it is 151, I'm guessing that would be 150 picofarads, which would be C6, hopefully. Right there. And we'll do the next one, which says 104. Which would be 104 would be 0.1 microfarads, so that would be C1. C1, 104 goes to C1. And it's right there. And then we have our last one. Oh, I tell you what, I could almost learn this off by heart. It's not like the resistor colours, but then we've got one here which just has 1 on it. Which, looking at our footprint, I'm just trying to see which ones do we have we not filled. Looks like C4, and C4 is apparently 1 picofarad, so that's probably 1 picofarad. Yeah, okay. Slightly a bit guessy-ish. We did a bit measurement-y, but mainly guessy, but I think we're going to be okay on that. So I'm just going to push those through. So if you've got them, try to wiggle them in, but don't push them so hard that you're going to smash the ceramic of it. Now, you could just flip this over and solder it. I'm going to do it from the top because they look like they're all going to fall out when I turn it over. And I prefer not to have to deal right now with that. Oh, it's very exciting though, isn't it? We're not really far off. I'm going for a hybrid solution, by the way. Look, I've only done one leg of each. I like the gamble. If I do the wrong leg now on the bottom, it'll fall out. It's absolutely fine though. Let's get in there. That's those. So while I'm removing the legs, I'm just having a look at see what's left. We've just got a couple of electrolytic capacitors. another switch, a rotary switch, a BNC, a header, and we're going to be done. That we really only got a couple of minutes work left. The rest is plain sailing by now. So we have this slide switch, which I don't know, is that part of this? Yep, it is. Goes on there. So let's poke that switch on. So if you're into your retro computers or your analog electronics, your hi-fi, this could be quite a useful gadget really. I'm not sure on the speeds and all that, and I'm going to tell you an honest truth that although I've used scopes for years, and you know I do use a scope fairly regularly. I've got one by my desk in permanent setup. That's how regular it is. I still don't really understand the whole sample frequency and all of those things. Bandwidth. It confuses me. It's a bit like cameras, you know, you get to understand what's the aperture and shutter speed and all of those relationships, but then by the time you take a photo you've forgotten it. It's kind of like that. So you would have to look up the specification for this, what I'm saying. But I suspect, my honest suspectation is that it's going to be really adequate for your little retro projects. You're not measuring like bus speed on a SPI bus running at 80 megahertz or something. Okay, so this one looks like 100 microfarads. 100 microfarad cap is going to be, oh, they're all the same. That's fine. That's great. So you've got the short leg is negative, the long leg is positive. If you get confused, you can see a negative actually on the can right there by my finger, and that's on the short leg. So look at the board. This one's marked with a positive and negative to make life easier. Long leg goes straight through that positive hole. And again, all three the same. We are very lucky. We should feel that luck. So we can turn it around gently, gently, gently. Poke it through like that. You can see the dead legs here. And I'm pushing down, holding it. Waiting a little moment, pushing it down, holding it, waiting a moment. Now these are just tack solders because the chances are it'll need pushing down. That one, you've got one sticking up right there, that's going to need pushing down. So we took him down to Chinatown. That's done. Oh, I could do with Chinese food. Spring roll, please. Get me a spring roll. And then, you know what? I don't really like those tiny spring rolls. I'm talking about the big ones. Those tiny ones are no good for anything. There's too much pastry, doughy stuff, whatever is the shell of a spring roll to filling ratio. Can't be having that right now. BNC connector, let's poke that through. Oh, ho, ho, ho. That is a hefty boy. Hefty boy, nice. You can see, make sure your iron's nice and hot. If you need it, get some flux on there. Look at this. This is a good example of why you need flux. So I'm going to do it without, but I'm heating this bad boy and it don't want to go. Let me clean my soldering iron and try again. Right. You've got to heat all the metal of that BNC connector to even have a chance of your solder flowing into that joint. And ouch, it's really hot. It did flow in there, but my gosh, it's not good flow. Because you can see I'm holding the solder on the other side of that component leg here. It's only just started to melt. There you go. Boom. And I'm going to do the other one now because that connector is probably nicely heated. And it'll feel like you're holding it way too long. And just be careful. Once you're done, let it cool down. So that way you'll avoid getting burnt. But two, if the plastic in it's got soft, if you just let it harden back up, it'll be fine. So that's, if you think about it, a lot of these components that go through reflow ovens, they get heated to the point where the plastics melt. But because you're not jiggling it around, it's okay. And that's still piping hot. That's got a lot of hot in there, but that's fine. We're just going to continue. We've got a pin header to add right here. Just step 6, pin header male. Let's get pin header male. Aren't all pin headers male though? Surely it would be a pin socket if it's the female part. I've literally never thought about it before, ever. And we're just going to solder those. And again, well, these are all the analog side. This is all like the little game controls. Look at that. It's got a nice little interface going on here. And they're all touched up. Nice. So that is, according to the instructions, finished. That's the finished board here. So just to recap very briefly, we've got the DSO main board, and now we have the analog board, which is doing, to be honest, most of the real work. So I'm going to flip over the instructions. Oh, it says we're finished. Okay, but didn't mention anything about this guy. I can only assume that that would go here. And it can only go one way. That's fine. Why am I not seeing that? That is a... Let's just have a quick look at the instructions here. Maybe, just maybe, because we do have another page somewhere. It's right here. Quite nice if this had a rechargeable battery in it. So that's the calibration guide. And okay, it does cover that. Rotary encoder solder. So they're actually showing the rotary encoder going on a separate board. Look at this thing. So they're saying to solder the rotary encoder to this board. I wonder if it's just to give it some additional height. But then what they're showing here is the rotary. Okay, let's just follow the instructions. I can see what they're doing. It does seem strange, but it makes sense. It's basically they're setting back the rotary encoder. So this is more like a spacing board. And I'm just wiggling it all around. It's not totally behaving itself, but you're making sure that the silk screen of the rotary encoder is on the top here. That's what it's asking you basically in the instructions, saying make sure the silk screen is on the top. So we're going to solder that down. So I suspect you've got options. Probably if you bought this without a case, they wouldn't have given you this small little PCB, because it's really just a nicety for mounting up that encoder. Okay, so that's the encoder nicely soldered there. That's not going anywhere. Still toasty hot. So they're saying fit the LCD into the panel. Ah, so you're supposed to fit the LCD into the panel. I didn't do that. I already glued it to my main board. Don't glue it to the board yet. Okay, that's fine. Let's see what they're going here. Let's try to work out what they're saying. I mean, why are they worried about the fitting? I think the fitting is fine. That's pretty good as it is. But I will take off the screen protector, because those are always impossible to take off. You notice in all these devices, they fit them and then you can't get to the little tag. So there's the screen. And yay, I fitted it. More or less. Okay. Fold the main board over while keeping the LCD in place. Okay. So that's basically saying do that. Okay, fine. Now they want you to fit the rotary encoder to the front plate like that with the screws, and it's 2x4. Now I don't know if they're big screws or little screws. We've got different size screws here. Some longer, some shorter. And we're going to go for the smaller screws because to my eye that's nearer 4mm than the other ones, because the other ones look like, dare I say, 6mm. That's one. And that's two. So you can see the rotary encoder is nicely positioned now in the middle. Make sure the PCB evenly touch the front plate. So I think it's a good opportunity now to solder that rotary encoder because it is positioned where we want it. So the reason you don't solder it first, I guess, is you don't know where it's going to need to be ultimately height-wise. So I'm just going to let that cool. I don't think we need to trim it, so we're going to leave that alone. So I think, looking at what's left, this is just really the final assembly. So I'm going to empty out all the screws here, put them aside. In fact, look, you can get your rotary encoder knob on. Oh, and it's got a click as well. This is going to be good. Okay, so it says get the back panel here, and this is where we start to install these plates. And I didn't cover it in this video, but I did in an earlier one. The quality of all of these bits and pieces is really nice. So this is a very professional feeling kit. I mean, look at that. It's even got the cutaway here so that when you install it, ooh, see, that's nice, isn't it? Very nice indeed. So we've got our panel here. We're going to mount it the right way. It's got all the markings on it too. I wonder if you can buy this as a ready-made unit. So that's looking absolutely as it's supposed to. Now, we were speaking of cameras, weren't we? I really need to change my aperture on here to stop it being so blurry. So I guess we need some more of those small screws, and there's 4 of them are going to go in here, 1 in each corner. It's one of those kits that gives you a lot of confidence that when you're done with this, it's just going to work. You know, you'd have to have really messed up something bad. But at the same time, I'm quite curious about the whole calibration side. I think that's the bit that is where the rubber meets the road on this. If you're going to get something usable or not, it's whether or not you can follow those calibration steps and they actually work properly. Got that in there. And you see you've got that little header there. There is actually a corresponding socket on the other board. We didn't have to fit it. It was a surface mount socket. So I like that they've got a separate analog and separate digital side on these. Right, so we've got that in. I'm studying the instructions off camera here. Combine the front module and the back cover. So I think we've got some switches on the back as well, the bottom. So, and we've got this. I suspect it's not sided, so we're going to have to just push this through into this frame. Oh no, it's saying that frame doesn't need to go on just yet, so I guess we don't worry about it. So we're just going to poke this through, and we've got to press these 2 pieces together whilst putting that little Lucas connector through. I guess the frame would have just been one thing too many. Okay, there you go, that did rotate round. So there's that little pin header just in there. I know you won't be able to see it. Yes, there. Make sure that's aligned. I mean, if you've got this far, you should be pretty aware of what you're trying to align and not align on this. And that is clipped in for loads of fingerprints on the screen. And then we're going to push this part on. Ooh. Just working it around. I think I'm not quite convinced, so I'm going to turn it around. I think it does seem to have a thinner side and a fatter side, so I'm not sure which way you want it, but I'm going to try both. Oh yes, that's much better. So it'll only go in one way. That's a bit of a gotcha. Just play with that. Make sure you've got it the right way. Yes, 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 so much yes. I'll have what she's having. Get some screws going on in there. We've got the 1. We've got the 2. We've got the 3. Hello, hello. We got the 4. Come on now. Have you seen those little electric screwdrivers that are teeny tiny ones? They look quite interesting. I wonder if they would help in this. This is the first time I've ever had a screw that didn't want to go down its own little hole. That's fine. We'll come back to you. We'll leave you for now. You can chill, take a time out. And I'm just putting, oh, I think it's worked its way in. And we'll start back at the beginning because I didn't tighten that one up all the way. So, that's looking really realistic, guys. Look at this. The quality of the lettering is good. The switches. Wow. It's amazing what they're kicking out now. Attach knob cap and done. Oh, bum. There was a calibration step. I skipped it. I missed it. Okay, just to show you, the calibration guide goes through to basically say turn on the test signal output, and we're running it at 50 millivolts with DC coupling. The coupling switch is here on the top, but that's a DC, yeah? So you hold that down for 3 seconds till that blue thing comes up there, and it's telling you the amplitude of the test signal. So you can have a 3v3 or a 0.1, that's absolutely fine. But you can see the shape of these, it's kind of curving like that. If you see the slope, it's kind of got these weird curves, and that's what we've got to tune out. So I got to take the screws back out of mine. For you, hopefully you didn't get this far. If you've got the cover off, brilliant. For me, I think there's a gotcha here on the instructions, because the 2 screws you have to adjust, the 2 capacitors, are actually in there. They're in these 2 little cutaways, which you may just see in there. You get them right in there. Now, these would be really adjustable if you could take off this front plate. Now, to get this front plate off, though, you need to make sure the adjustment knob that we had here, that we screwed in, is removed. Ugh. Which is no mean feat. And then you have to unscrew that top board. So I think, be aware, maybe do what I did rather than what the instructions are telling you for this, because I don't think it's quite optimal from adjustment standpoint, but that's okay. We'll just do it quickly. I'm doing it so you don't have to. Now we'll just take out that. Ooh, getting all mixed up here. Your handle. So you could see there, though, those are the 2 adjustments, and it looks like one is responsible for the 3v3 range, and one is responsible for the lower voltage range. It's something like that, so we need to adjust both, basically. Now, we're not going to get this plate off unless I can get that knob off, and I really don't want it to break. Whew, that was hard work. Okay, let's start again. So push your board in like that. Perfect. You can see now you've got full access. I think this is what they would have intended it to be. I mean, these case variants are probably something that's come afterwards. And we're going to attach that. So that's set to DC. We're going to attach the positive to there, and we can quite clearly see our interesting waveform. So I did a little bit of fiddling to get it like this. It's really cool, actually. I'll just give you a quick overview of the motor. I've got just at the bottom here. So when you've got nothing selected, that's just moving your cursor position, so you're moving it up and down. When you push a button, you can see it selects a box around it, so that's telling you the voltage per division, which is cool. That works nicely. then it's the seconds per division, so you want it somewhere like 0.2, and then it's the trigger, because it has automatic trigger or single trigger. Look, really cool, which is really handy if you're trying to capture something, and then you can push this button here to hold the signal on the screen. Now let's look at the two adjustments. We've got two at the top to deal with. We've got this C3 and C5. C3 we're going to do first because we're on the 0.1 volts test signal range. So I've got the screwdriver in there and I'm going to twist it. Look, see what it's doing there? Nice. You can see that changing ever so slightly. Look at that angle there, yeah? You want to get it as parallel as possible. So go one way, go back, and then twiddle it a little bit till you get that as parallel as possible. And then you push the button down. Oops, sorry. Hold the button down, back again to the menu to come up. Now we're in the 3v3 range. You see this, it's a similar thing. But this time I'm going to lower the volts per division so we can see the signal on the screen. And this is the C5 adjustment. And it doesn't look too bad to me, but I'm going to put the adjuster in there anyway. I don't know, you know, I think that's actually pretty good. So let's just check again, everything is fine, and we're going to go back to the other range. I think that looks about as good as you're going to get. I've set up a little test rig here. I have a kit that I previously assembled and purchased, which uses some sort of chip that gives you a square wave or a sine wave or a triangular wave, and you adjust them by adjusting these various jumpers to give you the different range. And then you've got the amplitude, you've got fine, and you've got coarse. So you can see on the screen we've got coarse, so that's a coarse timing adjustment there. And then we've got a fine, so that's again more of the same really. And amplitude, not sure that's doing too much, but that could be because we're on a square wave output. And the jumpers here, it says 65k to 1 megahertz, and you can remove the jumper and then just put it somewhere else. So this is the 3k to 85 kilohertz. So actually it's already on the highest frequency that this board will do. And you can see we can wrap it right round to there. And we're on a 1 millisecond range. Now let's try putting that on the sine wave. Let's see what we get there. Now the amplitude is doing something, but look, it's maxing out. So we won't change the division. How about 1 volt? There we go, 1 volt per division. So that's 1 volt per square, and you can see that's looking all right, isn't it? It's quite a sine-ish wave. I wouldn't complain. And you can see in the top right corner it's triggering, saying trigger, and pushing on hold there. And then you can load it back up. Interesting enough, so when you deselect, and your last select thing was the volts per div, it's giving you that. But it's also got something similar here, and you can see there is a cursor at the top. So if we push hold, look, it has a memory. That's amazing. So it is giving you a memory. It does have a buffer, so that's really useful. Sometimes you want to trigger on a serial or I2C communication, and you'll catch a bit of the lead signal, and here look, you can just scroll through it, which I think is okay. And there's obviously going to be some other functions that this thing can do if we go through all of the menus. Like here you've got normal, auto, single step, I think. Yeah, so you can see there, see it runs for a bit and then it stops. So it captures the signal you want and then lets you eyeball that up. And what's this saying? Oh, this is the, you see here, that's the trigger voltage. So if we change this to auto, and it's running, yes, you see here? So it's not triggering at all, it's just running, it's free running. And then once we put our cursor down to say where we want it to be, look at that. That is cool. Cool indeed. So what more to say? Not much. I'm going to have a lot of fun with this. I'll put the links down below. This was on Amazon. It's the DSO Shell DIY kit. 15001K if I am not mistaken. And that is absolutely stonking. Really. I mean, I think that's a very useful kit, and we're going to show that, I think, in more future videos, because that'll be really far more convenient than me setting up a second camera to show the oscilloscope for this sort of thing. Fantastic. Go out and get this kit. It was really easy to make, and my gosh, useful. That's one of the biggest changes. Please like, share, subscribe if you're that way inclined. Come chat to me on Discord if you want to buy me a coffee. The Patreon links are down below. And as ever, thank you for watching.